Hi, I'm John Imms with CleanSpace, and today I'd like to talk to you about our powered respiratory system. I'd like to talk to you about CleanSpace 2. CleanSpace is a new concept and a new technology in providing respiratory protection. Traditionally, PAPR products are a constant flow, belt-mounted hose to a head-top product. CleanSpace takes a very different approach to providing this level of protection. Our product is very simple, it's very small, it's very light. It's very compact, very comfortable to wear. And we have achieved this by flowing the air in a very different manner. So CleanSpace is not a constant flow product. We would call this a demand flow respirator. We provide air to the level that the wearer needs to maintain a positive pressure. I'd like to start by talking about the filter system and the motor unit that comes with CleanSpace. When we look at CleanSpace, the simplest thing is if we start at the back, and at the rear of CleanSpace we have the filter. This is the filter cover. We have a clip which we pull up to reveal the filter. Now this is our low profile filter. This is a P100 high efficiency filter. Okay, can't be put in incorrectly. It can only go into the system one way. So this is providing the highest efficiency filtration protection that you can get. It's very simple. The cover just closes over the filter like so. We close the clip. The cover provides moisture protection. This is a rain cover, and so it enables us to be working in damp environments. So let's look at the control panel on CleanSpace. You'll notice that we have two buttons. We have some battery indicator lights, and we have a little filter indicator light over here. To activate CleanSpace, we press and release the on button. That will illuminate the lights, the battery indicator lights. You may notice that you can hear that the CleanSpace is not running. Now, typical constant flow powered respiratory system, when we hit the on button, the motor will start running. Those type of products are designed to have a consistent flow at a predetermined litres per minute to maintain a positive pressure inside the facepiece. CleanSpace is not running because it's in standby mode. Now, as you can see, the design of our product is very different to constant flow products. We are not relying on a bulk volume of air to maintain a positive pressure. CleanSpace has inside it a pressure sensor, and what the pressure sensor is doing right now is sampling the ambient air pressure. It's sampling the in-mask air pressure, and 100 times per second it compares those two pressures. And so it's in standby mode waiting for that pressure to change. So at the moment the pressure inside the mask and the pressure outside the mask are the same, and so the unit doesn't need to run. When we put the unit on and we take a breath, we momentarily drop the air pressure inside the mask, so it goes lower than the air pressure that's outside the mask. That will activate the motor, and we then start delivering air. Now that air is delivered in such a way to always maintain a higher pressure inside the mask than outside. So that overcomes the effect of breathing and dropping the pressure, perhaps some leakage which will drop the pressure. 100 times a second we're comparing, and we know how to adjust. So we're confident that we're always maintaining a positive pressure inside that facepiece. If we look at the battery indicator lights, okay, I have two lights illuminated here. A fully charged battery would be running 3 lights. We run a lithium polymer battery. Now lithium polymer has some benefits. One of the main benefits is the speed of recharge. So our product, from dead flat to fully charged, takes a time of 2 hours. We also have the ability to be able to give short charges to our battery. So if I come in at lunchtime, I can plug my battery in for half an hour and give it a quick charge without damaging the battery. The half an hour charge, we will add a good hour or two to our run time, which enables us to get a very long run time out of our battery system. Clean space varies in terms of how much the motor works as to how much our body is working and how hard we are breathing. So we would call this a nominal 8-hour battery, and that run time can fluctuate a little bit depending how hard we're working. But we have that ability to give constant top-up charges. We have a flow test button, which I'll show you in a minute if someone wants to grab that yellow thing for me in a moment. But we also, I'd like to talk first about our filter blockage alarm. So Clean Space has a filter blockage alarm built into the system. Now this is an early warning alarm, so it's designed to activate when the filter has approximately 15% of its capacity remaining. Now that's an early warning system, and we've done that on purpose. If you're working in on an important task and the alarm goes off for your filter, you may not necessarily have the ability to come out and change that filter. You've still got 15% of the filter life remaining. If you press and release the on button, it will cancel that audible alarm. Now every 15 minutes until you replace the filter, that alarm is going to kick in again. It's a 75 decibel, it's a double beep, so it's a beep beep. If you hit the on button, it'll cancel the beep. You can continue working, but every 15 minutes it's going to go off. When you finish the task and you come out and you have the ability to change the filter, the alarm will go away. Now the filter alarm enables you to gain a full life out of your filter. It's very difficult to tell visually if a filter is used up. So it enables you to get the full life out of your filter, and it also gives you the confidence that if that alarm's not going off, your filter is in good shape, okay, and you're going to be protected. Now you may notice that the green battery indicator lights have gone off. That's because I haven't actually put the mask on yet. I haven't activated the motor. The product will stay in standby mode for 3 minutes. So on the bottom of the device we have the recharge port. So this is a DC jack system. Look, recharging Clean Space is very similar to charging your mobile phone. The jack is put into the port, and then the block is put into the power supply. So it's a very simple recharge system. Clean Space 2 is available with 2 filter options. So what we have fitted here right now is what we call our low profile filter. Let me just open up the filter cover again for you and just show you. So this is a low profile filter, P100, high efficiency filter. Okay, we get some excellent run times out of our filters. One of the benefits that the demand flow system that we run on Clean Space gives us in terms of filter life is airflow through the filter. So a lot of products on the market providing PAPR protection are constant flow. These products work very well, but are pulling constantly through the filter at, let's say they're running at 180 litres a minute. They're pulling 180 litres a minute of air, but also contaminant and particulate through their filter system. Clean Space on average is running around 55 to 60 litres a minute of air through our filter. So we're much closer to a negative pressure mask airflow. And as we know, negative pressure masks tend to get a longer life out of their filter because there's less airflow and less contaminant coming into the filter. Clean Space is on that end of the mark. So our low profile filter gives us some exceptional run times, or filter lifetimes rather, because of that reduced flow. For those areas though where we have very high particulate count, we also have our high capacity filter. Now the high capacity filter contains the same filter media as our low profile filter. This is a P100 high efficiency filter. It differs in that it has roughly twice the surface area contained inside this filter. So for those areas where we have very high levels of dust, the high capacity filter may be the filter for you. Okay, I'd now like to talk about fit. So CleanSpace is obviously a very different design. We don't have the traditional system where we have a variety of different head tops that are used. The reason for that is we don't need head tops. Our product will match and fit with all PAPR products that you're liable to come across in the workplace. It's a very simple system. We have a half mask. Now traditionally half masks would have a frame, we would have an elastic harness with a cradle, and that part of the half mask system is designed to get fit. Now we achieve fit with CleanSpace in 3 ways. You'll notice that I have a neck pad fitted to the device. Now this is a thin neck pad. We also have available a thick neck pad, and what we're doing here is we're playing with the distance between the motor unit and the harness. I would have to say that probably 90% of people using CleanSpace are using a thin neck pad. The thick neck pad though is available for smaller head shapes, head sizes. On the side we have adjustment on both sides of the air bellows, and we also have 3 size masks. We have the large, we have the medium, which is I have fitted to the CleanSpace at the moment, and we have the small. Let me just show you the difference between, to give you a feel, between the large mask and the small mask. And you can see obviously the face size is significantly different, but also the larger the face piece, the longer the side arms. Okay, so it's a combination of neck pad, adjustment on the side, and the correctly sized mask, which enables us to get a nice comfortable fit. The other thing which you can see on CleanSpace that I'm holding here is the harness. Now we recommend that you do use the harness, and it's the 4th component, if you like, to fitting CleanSpace. So CleanSpace is not a constant flow product. We are a demand flow system. Inside CleanSpace we have a pressure sensor that is sampling the ambient air pressure and sampling the in-mask air pressure. Now it's doing that comparison 100 times per second, every millisecond. We are comparing external pressure and internal pressure. As you can see, the CleanSpace is not currently running, it's in standby mode. When we put it on and we take a breath, we draw the air pressure, the air out of the mask, which reduces the air pressure. That will activate the motor. We then start to deliver air in such a way to maintain a positive pressure or a higher pressure inside the mask than outside the mask. I'd just like to demonstrate that for you. So I'm going to fit CleanSpace. I'm going to take a breath, and you're going to hear the motor activate as that pressure drops. So let me just demonstrate that for you. I fit the mask, I adjust it. You can now hear that the pressure sensor has responded to the drop in pressure inside the mask. It's now giving me airflow at the level that I require based on my breathing rate. Now if I have a leak, if I have a break in my seal, remember CleanSpace is comparing the inside and outside pressures of the mask every 10 milliseconds. So I'm going to break the seal and you'll see how it responds. You can see there is an instant response to any change of pressure inside the mask. This is ensuring that our airflow is always outwards. I'll now take the mask off by undoing the side clip. The pressure sensor is now comparing those pressures. It's sorting out what's happened to the pressures because they've changed. It confirms that the pressures have equalised, so the pressure inside the mask, the pressure outside the mask are again equal. It's gone back into standby mode. Now it will stay in standby mode for 3 minutes. And if that pressure situation doesn't change within that 3 minutes, it will then switch off. To fit clean space is a very simple process. The easiest way to put clean space on, okay, you'll notice on the side of the respirator, we essentially have 3 buttons, okay. The first button, as you can see, is holding the mask. The second button has a rough finish. This is the mask release button. The third button at the back here obviously is to enable us to adjust the side arms to get a correct fit. So what I'm going to do is I'm going to release the left-hand side of the mask. Now you can do either side, it doesn't have to be the left side. That has separated the mask from the motor unit on this side. I'm going to sit the motor unit on my neck like so. Now it will sit there, okay? It's not going to fall off, it can sit there quite comfortably, almost in park mode if you like. Now with my left hand I take the mask, with my right hand I take this side of the harness, I place the harness on my head, still holding the mask, I place the mask on my mouth, I then connect the clean space and I breathe. Now what I'm going to do is just adjust the harness so that it's comfortable. And now what I want to do is I need to ensure that the mask is comfortable and that it's not leaking. It's very important that we don't over-tighten a clean space respirator. So I'm going to just adjust that slightly. My mask no longer has any leakage and it's nice and comfortable. You'll notice that I still have movement in the motor system as it's positioned. Okay, that's how clean space should be when you're wearing it. Now to take it off, it's just the reverse. I'm going to find the rough button. If you run your finger down the harness and go back 1 button, you'll find the rough release button. I press it, I release the mask, I take clean space off. The pressure sensor is going to evaluate the pressures, determine that it's safe to go back into standby mode. In 3 minutes that's going to shut down. I'd like to talk a little bit about the fit components that come with clean space. As I've mentioned, we have a neck pad, we have a harness, and we have a mask. Okay, so I'm just going to remove those components. I'd just like to talk a little bit about them and then like to show you how you actually fit them to the clean space. So if I start, I'm going to take the neck pad, okay, and the harness off, and I'd like to talk firstly about the mask. So I'm just going to remove the mask by pressing the mask clips. Our masks are made from a silicon material. Silicon is a super comfortable product. This is very soft, it's very pliable, it is very easy to clean. Now we would recommend warm soapy water, rinse the product off, but you can use any of the normal mask wipes that you would typically use for a half mask product. The silicon is very resistant to chemical. It's also very resistant to heat. So the silicon material that this mask is made out of is rated to 300 degrees C on the product. Okay, so if you happen to be using clean space in a welding application, say where you've got some sparks flying around, you don't have to be concerned in regards to the performance of the silicon material that we use in our product. One thing you will perhaps notice as you use clean space and you have the product for a reasonable amount of time is that it will take on a slight yellow tint to it. Now that's very common with silicon. We actually can't stop that from happening. It's how it responds to UV. The discoloration though has absolutely no effect on the actual performance of the product. Okay. If we have a look at the neck pads, so as I mentioned we have 2 neck pads available for clean space. We have the thick and we have the thin. Now both of these products are able to be cleaned. So they can be washed, they can be rinsed. The thick neck pad has a foam inner, so that needs to be squeezed out a little bit. but would typically dry overnight, be dry ready for your shift the next day. Our harness has a webbing material and it also has elastic. Again, this can be cleaned and should be cleaned, rinsed out, and will dry overnight for use the next day. I'd just like to take a moment to talk about the flow test function on CleanSpace. Now you'll notice on the control panel that we have two buttons, the on button. We also have the button marked flow test. Now all PAPRs under the requirement under the standards needs to have the ability to test the flow of the product to ensure that we have the correct airflow coming through to meet the standards requirements for the product. Typically flow testers are a tube with a ball and a line type system where you would put it in the device, turn it on, and the ball goes over the line. That would signify that we have sufficient flow. With CleanSpace, each CleanSpace product will come with this yellow clip, which is actually the same clip that we use for our masks. It has a reduced opening, okay, and the CleanSpace product is calibrated to the airflow that comes through that opening. So to conduct a flow test, we turn on the button, the on button, which activates the device. We fit the flow test clip to the left side bellows. Now this is where the airflow is coming. There's no airflow on this side of CleanSpace, okay? Now with the device turned on, and we can see it's on because the green battery lights are indicated, we press and release the flow test button. Now you can hear that CleanSpace is flowing flat out. It's going to do that for about 10 seconds. And at the end of that, we're going to get either 1, 2 or 3 green lights. And you can see that the green lights have gone off quite quickly. But we actually had 3 green lights there. 3 green lights signifies that we have excellent flow. That's the flow that we would expect to see. The ball, if I can use this as an analogy, the ball is well above the line. If the ball was sitting on the line, we're going to have 1 light, okay? If the ball went under the line, which means the flow is dropping under the requirement of the standard, the 3 green lights are going to flash and the red filter blockage light is going to illuminate, okay? Now if that should happen, what we're doing is we're essentially testing the battery charge and we're testing filter blockage, okay? So if you have a situation where you do a flow test and the 3 green lights flash at you, the first thing to do would be to check your battery charge, recharge your battery, and check the condition of your filter.